Hello, hello JB. Okay. Oh. So, can you see the screen? All right. Okay. Can you present? All right. Please proceed.
Good afternoon, everyone. For our group, our problem review is for spectacle. So for our problem, the problem we want to highlight is the lens cover with fog. For next page, next slide. Okay, thank you. So the problem is we want to highlight is the lens cover with fog. What is the consequences? So when this happen, because we have lack of visibility, limited visionary, and loss of eyesight. Then who will face this problem? Whoever wears spectacle, and this happen when there is two different temperature environment. And this happens is due to the condensation of water in our lens. Then this happen when any is happening when any time when the environment with two different temperature. For example, when we are in the car, there is with aircon, then we go out from our car which very hot, then our lens will cover with fog.
Okay, then, doctor, next slide. Okay, this is the problem review. So normally people will not face this kind of problem when the people do not wear any spectacles. So the problem only start when a human have short-sighted or long-sighted, then they have to wear the spectacle. They will have the problem of having the fog on cover on the lens. So when the people start to wear a spectacle, there will be the problem that how it affects the product, and will be continued by HD.
Yes, Assalamualaikum and good afternoon. So we continue with the problem review. Okay, when the humans have the long-sighted, they have to wear the spectacles. So how the product itself, how the problem itself affects the product when the fogging, cloudy, and covering the lens. Then how it affects human. So it affects through the lack of visibility after fogging created on the lens. And then how do the fog happen? Yes, again, as discussed in the earlier slides, the fog actually created from the two different temperature environments between the cold and hot, and also the drastic temperature difference when a human transferring from one location to a location. Example, like when you're getting out from the car. So the problem here is lens cover with fog. I think this will conclude our main problem identification.
Okay, thank you very much. Okay, so that is the presentation done. One of the presentation completed by Team JB. Okay, so due to limited time, so we need one group from KL, and then we will continue again with our lecture. So beside that, any group that already completed the slide, please email it to me, okay, by today. So let's discuss on this group regarding with spectacles, okay. So I think this is a common thing that the user face regarding when they wear these spectacles. Okay, so here is a very what you call standard, I will say a standard analysis on what is the problem is all about. Okay, so we use a normal kind of question, for example, what, and then they mentioned about what is the consequences. Okay, and then who faced the problem, where does it happen, why, how does it happen, uh, why does this happening to the spectacles, and when the problem happened. Okay, so let's review first what. Normally the question what is the issue or the problem. We can what you call in here they mentioned about the consequence, the impact. So if we want to know what is your problem, then normally people will say anything between the sky and the earth. Okay, but in this kind of exercise we can see that it could be like other group also mentioned the similar thing. What is the problem? The problem is there is fogs on top of the lens. That is the problem. If there is no fogs on the lamp, then there is no problem. Very straightforward. Okay. Who? Okay. Who faced this is in generic, like everybody wears spectacles. Okay. So everybody that wear these spectacles affected with this problem. Okay, is a very generalization, but there could be like a certain people who doesn't have the issue. There is certain people who have great problem with this what you call issue. So for example, like the magnitude of problem. Okay, magnitude of problem. It is so critical that it require the lens not to have fogs on the surface. Others like is no problem. There's no critical kind of thing, because when there is a fog and you've been interrupted, your vision is been interrupted. Okay, so meaning that it could be like we can categorize, okay, the target audience, okay, who highly affected with this what you call lens fogging. Okay, and then where the location. So when we say the location, it means that it's something related to place. Okay, it could be it happened in the spectacles, it's not happened to human, and it happens in a different kind of environment, in a very specific environment. Then the problem happen. If we in this room we don't have any issue in lens that have fogging. Okay, so why does we don't have the problem? Why does that problem occur over there? The fourth question is why. So it could be talking about the explanation. It could be like talking about the detail, the technical, the process, and what's not. So why does it happen means there could be like something trigger that create fogging. Okay, here this group mentioned about condensation. So why does the condensation happen? It go back to the question when there is two different temperature, meaning that there is a cold and there is hot. So that create condensation, and condensation create fogging. And then the last part is when. So it could be like when you ask this kind of question, it will interrelated. But you need to know precisely when it happened. So for common people, for people who face this problem, normally they are having this kind of problem when they are moving from a hot place to a cold place. It could be like outside the car, inside the car, or inside the car, outside the car. Which one is correct?
Inside to outside.
Inside to outside. Okay, not outside to inside. Okay. So this is
Sometimes, doctor, problems also happen when we drink hot drinks. Like
yes.
coffee.
Okay. So that is the specific part. So we try to understand that the situation happened in a very specific kind of condition because the solution is there. If you analyze deeper, you can find the solution is just around the corner. But if we answer all these 5 questions in very what you call generic kind of we answer it in very general form, it could be like anything that available between the earth and the sky. Could be anything. So the issue is the main point in using this 5Y is the specific condition. Okay. So what will definitely happen if this happen? Who will affected? Definitely happen to this person. Definitely happen to this location. Then definitely happen at this time. So that's why I'm using a very generic form for you to apply first before we go to the to using trees. Okay, and then okay, this is how we review a problem in a sequence kind of form. So first is there's no problem, which means that your spectacle doesn't have fogs. Okay, right now. Okay, example right now. But there is something that change. For example, like temperature difference. When temperature difference, what actually happens? Who affected with the temperature difference? The glass. Okay, the glass. Why does the glass been affected by temperature difference? Material of the glass, yes. What is it all about, the material of the glass? The content, yep. Yeah, why does the glass have the ability to anti-fog? Huh? Udara? Yeah, the air we cannot change much. It's something with the lens. What is the difference between the lens that have fogging and anti-fog lens?
Thermal transfer rate?
Yes, correct. So that is the characteristic of the lens that makes your lens fogging. And there is anti-fog that have different characteristics. That is the magic part. If we stop answering at anti-fog and fogging, that is not really what they call added value for you. Okay, we want to know what is the secret of anti-fog lens. It will involve thermal heat transfer, meaning that they can adopt, they are temperature proof, heat proof, or whatever it is. That makes the lens doesn't have any fog. So that's why we need to what you call map out the sequence, what actually happened and how does we go around that and find the solution actually is under your nose if you ask the right question. Okay, so I think one of the group from JB, another one group from KL. Sorry. Gmail. Mana tu? Hafizida. This one? Helicopter. Fall. This one? Rizal. Mana? Oh. Okay, best student. All right. Okay. Okay. So, okay. Oh, dia tak ada mic. Okay. Tak apa, tak ada mic, tak apa. It's okay. Apa AA ni? Apa? Episode. Tak apa.
Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, our team has decided the product that we're going to choose is a vacuum cleaner. As everyone knows, vacuum cleaner sometimes it happens to be that it's hard to store since it's a bulky. There is various type of vacuum cleaners in industries. The common vacuum cleaners that we have is quite bulky compared to the new version of it. So the secondly is the suction of a vacuum cleaner. There is a limited suction scheme where you need some angles to suck the dust. Third is the containers. The bigger the containers, the bigger the capacity of it. As everyone knows, after the suction, we need to clear out the containers, the dust out from the vacuum cleaner manually. How it the normal procedure for a vacuum cleaner. Last but not least, the noise problems. It happens to be when we, for example, when we sleep during the morning days and someone is using the vacuum cleaners next to us, it will of course create a noisy noise, disturbance. So JD will proceed the next.
On the so we affected all these problems. One is the manufacturing themselves. Think about the user. Where do we use the universities? It's all the houses, the offices, the hotels, and number 4 is the why question. So why it's because of the different compartments or less capacity, less limited size, the space of the container, all the specifications, also the motor performance and specification of the suction specification. Number 5 is when industry for cleaning purposes. Housekeeping, limited space to store, we have limited coverage or angles, so difficult like parts, it's hard to suck the dust. And
Hello, JB. Hello, JB.
Yes, yeah.
Yeah, we cannot. Do you see the slide?
Cannot.
Cannot. So ada tersepak lagi ke? Ada tak?
But now you feel. So what I feel.
Ah,
Okay, Karen.
okay. Okay. Next slide. Okay.
Okay. So as mentioned by the presenter before, we know that current vacuum cleaner is bulky, that it is installed suction limited small particles, container, noise problems, electricity consumption, and also limited coverage area. So we look backward. Why the problem is happened? Because of they want to limit and also reduce the compartment, but still remains the function. Besides that, they want to improve the suction system, increase the capacity, increase the suction capacity, upgrade the noise system, and also reduce the electricity. Introduce introduce green technology. Besides that, to optimize the flexibility of the vacuum suction head. So, we look back another step. The current vacuum cleaner is already meet the national or maybe international standard. Besides the consumer requirement and also design. That's all, Dr.
Okay, thank you very much. Okay, good from JB. So, okay, let's have a look. This team they are selecting vacuum cleaner. Okay, so it could be like they could when they start with what is actually have a lot of problem related to vacuum cleaner. Okay, it could be like we can start with at least one of the problem. Try to select, for example, like noise, or is it container, bulky, and what's not. Okay, so again, this kind of question, it could be like our first layer, we go by a very generic kind of thing, but related to problem solving, you should select and try to answer the question in a very specific kind of answer. Okay, so it could be like they are talking about what noise. Okay, what the type of containers they have. How do you define bulky? Something like that. It could be like suction small particle, or maybe the horsepower, or whatever it is, watt or whatever. Okay, so from there, from one problem, we could like find a specific who is highly damaged or affected by this kind of noise. Yeah? For example, we take noise. So the issue is the vacuum produce unbearable noise. And then who affected is people around them, especially if you are vacuum in this room. So everybody will be affected because of the noise. Okay, where actually the noise happen inside the vacuum. That's the source of noise. Okay, the source of noise. Okay, and then the sound reach other people's. Okay, and they are irritated by this kind of noise. So it could be like we need to focus on the noise. Why? Why does it so noisy? Why does your vacuum cleaner is noisy? Yes, motor. Okay, we know that this is the motor, but what actually happened in the motor that make the noise? Friction. Friction what? Gear. Okay. So the noise happen because of there's a vibration. Yeah, of course we are not all engineers or whatever, but we try to understand the basic thing. Okay, noise come from vibration of air, and it will reach your ear. Okay, so wave and what's not. Okay, so it could be friction between parts, or it could be friction with air. So by nature, motor have rotating kind of behavior. So we try to understand Mr. Moto. Mr. Moto is use electricity and try to spin, and that spin creates air suction. And air suction normally have air pocket and air noise, friction, and what's not. Okay, and that is how it works. Without the motor, there is no air suction and there is no noise. We want suction, but we don't want noise. Okay. So with that kind of specific understanding, I can clearly find a solution. Okay, because it could be like I can do something with the noise, I can do something with the friction, I can do something with your ears. Motor. So that's the source. Okay? Because you are what you call irritated by the noise. I cannot do much on the motor. Maybe I can do with something with your ears. It could be a solution. Problem solved. If I cannot do something with the ears, I can do something with the air. Any solution? Air? How to stop the noise by using air? Control frequency could be. Kita package it and don't let the noise noise damper, something like that. It could be like noise cancellation, because the noise is moving like this and you counter it with different and then they are cancelled, become sound. It could be like we can vacuum this room. There's no air particle. Then I cannot hear you because there's no vibration. So if you try to answer this 5 why question very specific, eventually you can find a solution. Okay, that's the gist of this activity. Okay, so I think we should move forward to our. So any group, please email to me. I will upload it in our Facebook, and we could invite other teams also to join this secret Facebook. Yeah, it could be we create a different one. Okay. All right. Okay. So we continue our class. So to others, they believe that 5Y and WH is just a kids kind of analysis to understand problem. But if you do it correctly, you should just only use this one tool, and using your creativity and innovation, you can find the answer. Okay, but we have trees. Okay, so this is the thing that we touched a bit in the previous class, and hopefully the other who doesn't join the previous class will understand this concept called system. There is 3 types of system. One is product as a system, a bottle, a watch, a smartphone. Okay. Another one we call it subsystem. Subsystem is whatever inside the system. So if this watch is a system, then the battery is subsystem, the strap is subsystem, the dial is subsystem, the board is circuit board is subsystem, the display is subsystem, everything is subsystem. A different definition of subsystem is component. Okay, even for human people like us, if we are a system, then subsystem could be the bone, the nerve system, the brain, the skin, and what's not. Okay. And then there's also the terminology called super system. Super system is whatever system outside your main system. So if human are the system, then whatever around us is super system. The chair, the table, the microphone, the laptop, the light, the aircon, the air, the oxygen, the nitrogen, and carbon dioxide, everything. Okay. So we should clearly define these three main categories. Okay. So in this slide, we show a bit of example pen as system. We can see in the upper hand, in the center part of that, we call this 9 window. Okay, the super system is paper, desk, chair, light, blah, 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 and many more. Okay. So that is considered super system outside pen. But inside pen, the subsystem is the component of the pen: ink, casing, what do you call, body, spring, buttons, whatever it is. Okay, so that is component. It is very straightforward. And then this 9 window, actually we taught in previous group, but for this activity, we need to categorize these three type of system only. Okay. Yes. It is related to the system. Yeah. Because for pen, we need desk to write on, papers, and then there's the people who use it, and then we also need light on what we are writing on top of the paper, the environment, or anything that could be related to the system, which is pen. Okay. So it's a very straightforward thing. So from here, we can create, we have a very quick exercise. Okay. You are working like side by side partner. Okay. We take like bicycle as a system. Please create 3 column. That the first column is super system, the center column is bicycle, and the final column is the subsystem. Okay, so please Google about bicycle, and what you should do is write down as much as possible what is super system and what is subsystem. That's all. Any bicycle. Okay. So I give you a bit of 5 minutes, 5 minutes or 10 minutes. Very simple exercise. So JB, okay, understand? Okay. Please create a table that mention one column mention about the super system. The center column just mention bicycle. The subsystem column mention all the components related to bicycle. Okay, please list down as much as possible. How to focus.
Dekat acara sub dengan super je kan.